Hi guys, today we're going to do basically the same thing we did yesterday, but today we're going to use a different unit. The unit we're going to use today is called radians. I know you've seen that button on your calculator where you can put your calculator in radian mode or degree mode. So what is a radian? Basically, radians are just another unit with which to measure angles. Just like we measure temperature, sometimes we use a Fahrenheit scale, sometimes we use Celsius. When we measure length, sometimes we measure miles, sometimes we use kilometers. And radians are just another way of measuring angles, another unit, and they're used primarily in higher level mathematics. This is the most important one to remember. 180 degrees is equal to pi radians. 0 degrees is equal to 0 radians. 360 degrees is 2 pi, because if 180 is 1 pi, it makes sense that 360 would be 2 pi. And from this one, the 180, we can derive all others. So if pi is like 180 degrees, then pi divided by 2, 180 divided by 2 would be 90. And 180 divided by 4 would be 45. And 180 divided by 6 is 30. And 180 divided by 3 is 60. So the most important one in my mind is 180 is equal to pi. So wherever you have a pi, you can think 180 degrees. All right, there is a way of converting degrees into radians. You multiply by pi over 180. So if I multiply 30 by pi over 180, my 30 goes into 30 once, 30 goes into 180 6 times, and I end up with pi over 6. 22 times pi over 180, that's 22 over 1 times pi over 180. I know 2 goes into 22 11, 2 goes into 180 90 times, and that would give me 11 pi over 90. All right. Now, if I wanted to convert from radians into degrees, radians to degrees. So the opposite of that is to multiply by 180 over pi. Notice your pi's cancel. We get 3 over 180, or sorry, 180 over 3, which is 60 degrees. Or like I did it before, I said, think of pi as 180. Think of that as 180. 180 divided by 3 is 60. That's the faster way. But this is the textbook method. If you get some numbers that don't work very nicely, then you can always use 180 over pi. My pi's cancel. 4 goes into 4 once. 4 goes into 180 45 times. 3 times 45 is 135 degrees. So 3 pi over 4 is the same as 135 degrees. All right, let's move on. And we've got draw the angle and state the quadrant where the terminal side lies. Okay, this is slightly more complicated than when we had it in degrees. I'm going to try to show you an easy way to do it. So think of pi in halves. So 2 pi over 2 is still the same as pi, or 180. Remember, 180 is pi. That's why I put pi right here, because that's 180 degrees. So to give it a common denominator, 2 pi over 2 is still pi. So I want to count off 5 pi over 2. So starting over here at the initial side, I would have 2 pi over 2, 4 pi over 2, and one more pi over 2 would make 5 pi over 2. And then this would be 6 pi over 2, which would be 3 pi, which would be 180 3 times. But we don't need to go that far. So 5 pi over 2 is a quadrantal angle. And we drew it, and we're moving on. The next one is 3 pi over 5. So this is pi. Pi is 180. So I'm going to write it with the common denominator in fifths. So 5 pi over 5. So I don't need to go quite that far. Half of 5 pi over 5 would be 2.5 pi over 5. So 3 pi over 5 should be somewhere right in here. And what quadrant is that? Quadrant 2. And now let's move on to reference angles. So a reference angle, recall, is the shortest distance back to the x-axis. So 7 pi over 6, if this is 1 pi, this would be 6 pi over 6 if I give it a common denominator. So from my initial side, which is 0 radians, from 0 radians to 6 pi over 6 radians, and then we've got 7 pi over 6 radians. 7 pi over 6 has got to be just a little farther past 6 pi over 6. And my reference angle is the shortest distance back up. That would be 1 pi over 6. So my reference angle is pi over 6. Let's try 13 pi over 2. All right, this would be 2 pi over 2, which is pi. This would be 4 pi over 2, which is 2 pi. So we've got 2 pi over 2, 4 pi over 2, 6 pi over 2, 8 pi over 2, 10 pi over 2, 12 pi over 2, and 13 pi over 2 would be right here. So my reference angle, the shortest distance back down to the x-axis, my reference angle would be pi over 2. All right, let's move on to one positive and one negative coterminal angle. So remember, to find a positive and a negative coterminal angle, we added and we subtracted 360. Well, in radians, 360 is 2 pi. So we're going to take each angle, we're going to add and subtract 2 pi from each angle. Okay, so let's add 2 pi. So 5 pi over 3 plus 2 pi over 1. Well, I'm going to need a common denominator. My common denominator will be 3. So I think that would be 6 pi over 3. 6 pi over 3 is the same as 2 pi, only we have a common denominator. And that would give me 11 pi over 3. So that is a positive coterminal angle. Now let's take 5 pi over 3 and let's subtract 6 pi over 3. And that gives me negative 1, or just negative pi over 3. And that is a negative coterminal angle. We could do it again. Let's do it with this 13 pi over 4. Let's add and subtract 2 pi. So we have 13 pi over 4 plus, in fourths, that's going to be 8 pi over 4. 8 pi divided by 4 is 2 pi. So 13 plus 8 is 21 pi over 4. Okay, now let's take 13 pi over 4. And this time, let's subtract 8 pi over 4. That gives us 5 pi over 4, which is not negative. So we'll have to subtract 8 pi over 4 again. And we get negative 3 pi over 4. And there we have a negative coterminal angle. We could use this one for our positive coterminal angle, or we could use 5/4 for our positive coterminal angle. The last thing we're going to do is find the complement and the supplement. So to find a complement, I know when it was angles, it was easy. But when you were finding a complement, you're taking 90, which is pi over 2 in radians, because pi is 180. 180 divided by 2 is 90. So we're going to take 90 minus our angle, and that will help us find the complement. Of course, we're going to have a common denominator for this one, which will be 6. So pi over 2 would be 3 pi over 6. That reduces to pi over 2, minus 2 pi over 6. And 3 pi over 6 minus 2 pi over 6 is pi over 6. And that is the complement. The supplement, we would need to take 180 minus our angle. Well, you know 180 in radians is pi. So we're going to take pi minus our angle. So pi in thirds would be 3 pi over 3 minus pi over 3, because 3 pi over 3 is still pi, minus pi over 3 gives us 2 pi over 3, and that is the supplement. Okay, down here we have negative 3 pi over 4. We're trying to find the complement. If one of your angles is negative, there is no complement or supplement. All right, guys, this was a little bit longer than normal. Sorry about that. I went as fast as I could. We can do more of these in class as well. Y'all have a great day.